Hello everyone. I apologize for being slow to get going. I am not used to this particular set of tools and I am learning. But I'm hoping that you can hear me and see me. My name is Craig Cornelius. I'm a software engineer at Google. I work on a team called International Engineering, and I have been doing internationalization for on the order of 15 years. My privilege tonight is to talk to you about using the internet and using tools that will help almost any language get on the internet. I also work with a group called Translation Commons, which is a nonprofit volunteer community, and it has several goals to sustain cultures and languages, but it also helps translation professionals with opportunities, and a key part of it is to share knowledge through courses and resources. The particular piece of Translation Commons that I'd like to mention is the language digitization component. And you can find this at translationcommons.org. I encourage you to explore this website. There's a lot of stuff there, but the part there is, that's circled there is the part I'm going to talk about tonight. The Language Digitization Initiative came out of the idea that we could work, that Translation Commons could be a partner of UNESCO's Year of Indigenous Languages, which was 2019. Translation Commons is also a partner in the Decade of Indigenous Languages, which is about to start in 2022. And one of the things that we developed in this direction was a document, which you can find at this website, Zero to Digital, a guide to bringing your language online, which we published a little over a year ago. It is intended for Indigenous communities and technologists and organizations who all want to work together to bring languages online that may not yet be well represented on the internet. My goal tonight is to help you understand some of the tools and capabilities that many communities should be able to use almost immediately, even if they haven't thought that they can use their languages on the internet. One of the things in the Zero to Digital document that is really useful is a set of two flowcharts, and I'll just briefly outline what they are. The first is evaluating the status of a language. So suppose we have a Native American language, or language from the Amazon rainforest, or perhaps a smaller language community in India or Africa, and that group wants to figure out how to get its language online. The questions that are asked in the workflow of this document include the first basic question: is the language actually actively used, or is it in revitalization? That question and the answers to that will help guide people in what they need to work on first. Now, of course, the internet can handle audio and video perfectly well, but of course the internet is also optimized toward working with text. And so the Zero to Digital document is focusing on text because that is something that really helps people use their language in a more sophisticated way. So many of the things I'm going to be talking about will actually be related to this aspect of using the internet. Texting, writing emails, creating posts, and other ways of writing language in textual form. If the language is written, then that's one step further along the workflow. And if it's already documented, that will help in other aspects of this. But it's important to note that the language doesn't have to be formally specified for people to start using it actively. But some decisions need to be made. Does the language have a writing system? From my point of view, the particular writing system that is going to be used is not so terribly important. Many different languages use more than one writing system. For example, Serbian is presented in both Cyrillic and Latin script, about 50-50 in that country. But and other countries have, or other languages have more than one script possibility as well. Many languages in India, for example, may use 1, 2, or 3 different ways of writing the language. But the important thing here is if one wants to use it in the internet, we need to know if the writing system is already standardized. And the best way of doing that is to make sure that it's in Unicode. If a person is looking at his or her language, trying to decide, can I use this online? The first thing to look at seriously in terms of technology is, how would I get the way I want to write my language standardized into Unicode if it's not already there? The language status also has additional suggestions that you can take a look at when you go to find this online. The next part of the workflow is the technology implementation. And this asks specific questions about what pieces you have already if you're wanting to digitize your language, and what pieces you need to both make the language usable in terms of displaying characters and also making it possible for people to find text that is written in this language. One of the things that people tend to forget about or not think of is that there are language codes, 2 or 3 letter codes for each of the thousands of languages in the world, and these language codes are indeed standardized, so that if one wants to indicate the Hawaiian language, you have a particular code for Hawaiian. If you want to use English, EN, but you may also specify language and region codes. So EN in ENGB is specific for English as spoken in Great Britain, and that implies other things about what one will see when one looks up resources online. For many of the languages we're talking about, they're not well-known language codes, but they are all available and can be found. Wikipedia is a great source for the actual 2 or 3 letter language code that is to be used. And this should be applied whenever one builds a website or whenever one uses or creates a video and the content of that language needs to be findable. One also needs a way of displaying characters, and we'll talk about fonts in a little bit, but Unicode fonts need to be available. If they're not, there are ways of developing them, and we have some hints in the document about how that can be done. And then if there is a font, is it available on the device that you're actually going to be using? And this is a bit trickier because while most people can easily add fonts to their laptops or desktop computers, adding it to mobile or other kinds of devices isn't quite so easy. And being able to read the language isn't all we need. We actually need to be able to create new text for that. And so typing, using a keyboard or another kind of input method is really important, and we talk about that coming up. And if one wants to use the language in a more sophisticated way, there's other data which can be added to using the Unicode rules and a resource called the Common Locale Data Repository. But we're getting ahead of ourselves a little bit. Suffice it to say that if you look at Zero to Digital, you'll find ways of thinking about your language and questions to ask to be answered before you can actually effectively use the language online. We also have lots of other tools and standard practices and resources in that document that may be helpful to you. What is the need? Well, hundreds of millions of people use the internet every day, maybe billions, and many of them already use one of the major languages. The top 100 languages or so in the world actually are spoken by the vast majority of the people in the world, but many other small communities would like to use their own languages. For example, Native American communities, some of them with only a few dozen or a few hundred speakers, still want to be able to use their language because, of course, language is critical to their culture and their sense of who they are and knowing their place in the world. And so preserving the language is more than just having a way to communicate. It's a way of being. The need for education and language technology is particularly critical when we're talking about education, especially of young people. Here is a school in Bangladesh. It's actually in the Rohingya community, and these children are learning to read and write in a Rohingya Hanafi script, but they're using a technology which doesn't need electricity, but they would also like to be able to use their own language digitally on their various devices Their parents would like to be able to communicate in this language, and the tools are becoming available. Now, you all know about ways that language is used in the internet, at least a few. It's used for communications, and some examples are text messages and speech to text from voice input, spoken output, closed captioning, machine translation. People also use it, of course, for publishing and using many other tools online. People scan documents and get digital versions of them. And of course, commercial and business and other information industries use language all the time. But native languages also can use the internet for more than this. They can use it to disseminate or create and disseminate educational materials, for example. There's strong evidence that young people learn very well in the language that they use at home, and then if they need to learn a dominant language, that can come later. But when young people are taught in the languages that they speak every day, then they learn better and become better students and have much better outcomes in their educational experiences. And of course, language is also necessary for user interfaces of all sorts, including those that have, for people who may have different abilities than everyone or than most people. The technology basics for using any language online are generally that we need a way to represent the characters. Of course, down underneath all the user interfaces are bits and bytes that actually represent the characters in digital form. We also need a display technology. That includes software and fonts that together can take the text patterns that are in the bits and bytes and present them as characters on the screen or in print. We need input tools, ways of typing, or ways of indicating the characters that one wants to store in a digital document. And of course, the applications that use these languages need to be able to use the fonts, to apply the keyboards, and properly generate the text that people are producing and accept it in all cases for all different purposes within a language. For example, a social media platform may not allow or may not understand a person's native language and may not be able to let a person type her name in that language, whereas the dominant language might be perfectly fine there. So applications need to be aware of languages and the various writing systems that are available as well. Just a brief statement about encoding. And encoding is simply the idea that we use a pattern of bits, effectively a number, to set up a matching between the number and a character that we represent. The ASCII system, the American Standard Code for Information Interchange, is a great one. It's used everywhere for basic Latin characters, but it only has 128 characters. And that, of course, is not sufficient for representing all the world's languages in the writing systems that people want. But basically, an encoding is a correspondence between a set of numbers and a set of characters. Unicode is a relatively recently developed encoding standard. It's on the order, it's getting to be close to 30 years old now. And Unicode was developed with one simple idea, that there would be one set of numbers that would correspond to the characters that would be used for all the written languages of the world. Each character has a unique code. So there are different characters for the Latin, or different numbers for the Latin characters, a separate set of numbers for Cyrillic characters, a separate set for Devanagari, a separate set for Chinese characters, a separate set for Myanmar script, and so on. Those characters do not overlap, so that people can actually take the codes for each of the characters in multiple writing systems and put them together in the same document without the document getting confused. The document will know that these characters are to be represented with a particular font, and multiple languages can be in the same document. It removes a level of fooling around with text when Unicode is used, because one doesn't have to worry, oh, do I have to apply this particular set of rules to interpret these particular numbers in this particular situation? Now, it's important to note that Unicode effectively is the standard on almost every computer and mobile device in the world right now. The Unicode standard is also constantly growing and changing. New writing systems are added, 3 or 4 every release of the Unicode standard, and it releases it once a year. I was just in a meeting today for several hours where people were proposing, in some cases, small additions and changes to the Unicode standard, and in 1 or 2 cases, completely new writing systems that were proposed to be in the Unicode standard. And this is an example of the Georgian writing system in one of the Unicode documents. As you can see, each of these characters has a specific code associated with this, and this code is written in hexadecimal rather than decimal characters, but that's just one way of representing it as a number. But the other writing systems would have different codes, and each of them can be looked up. If you're interested, of course, use your favorite search engine and look for Unicode and the writing system that you're interested in. Why Unicode? Well, the principal reason for using Unicode is that the codes don't overlap. So multilingual documents can use multiple scripts, and so multilingual documents can easily be created. And the next big reason is almost everybody supports Unicode. And the third thing, which is not so obvious, but I hope will make sense to you, is that every character in Unicode is more than just a place in a table with a shape. Every Unicode character includes not only its representative shape, but it includes the direction in which it goes. So Arabic and Hebrew and Adlam and other characters in those writing systems go from right to left on a screen or on a paper, whereas many other scripts go left to right. The type of character is important, letters, digits, punctuation, and so on, in deciding things like text layout. The Unicode characters, or the Unicode properties, indicate whether a character is a spacing character or not. And this is useful when a computer system is trying to figure out, how do I take this text and put it on a screen or put it on a page and figure out where to break each line of the text. Without that information, only very, very primitive processing can be done. And a fourth advantage of Unicode is that because it's a standard and it's public, anybody can create a font for it with the right tools and a little bit of knowledge. And so the specific way that the writing system may have been originally used in a community can be enhanced by people developing new fonts. Those of us who use dominant languages and have used computers a long time are very comfortable with seeing that a character has many different shapes. Those shapes are generally determined by the font. The Unicode standard, it's very important, does not say what the shape of the character is. The Unicode standard says this is the abstract idea of the character, and that, in association with a font that displays it, determines how it will actually look on the screen. But just like you can take English text or Russian text or Chinese text for that matter and apply different fonts to it to get a different look and style, you can also do that with any Unicode set. Now, just a little bit of history here. Some of you actually may know what a typewriter was. Typewriters have been around quite a long time, over 100 years, and they have a very specific relationship between the position on a physical keyboard and the particular character that appears on the piece of paper. And it's all a mechanical linkage, and it's really easy to understand what's going on here. It's easy then to think that your computer keyboard, if you're using a keyboard, is a physical keyboard, is much the same. A particular key on your keyboard is somehow connected to a particular shape on the screen. Well, the advantage of computer keyboards over manual keyboards is that we don't physically have to keep adding new mechanical devices to add new shapes to our computer input system, but the advantages of mechanical were that you could really easily understand the connection between what you touched and what you got. With a computer system, it's a little more complicated. People decided that they would build particular language keyboards, physical keyboards, and this is the case of French, where instead of a QWERTY keyboard, there's an AZERTY keyboard in place of the, or on the E, there's also an option for the euro in modern French, and this particular thing is, of course, quite nice and would be useful for a person using a laptop or desktop with the French language. However, it's really not necessary to have a particular physical keyboard to use a particular language on the computer. One should think of, instead of a mechanical linkage, there's a software linkage. What is that linkage? Well, when someone types or touches a key, that key is actually translated into a key code. And one way of thinking about it is that each of the rows, the bottom, next, and so on, is labeled A, B, C, D, E, and the positions on the keyboard are labeled from the left to the right, and each of them has a position. So C01, C02, and C03, and so on. The E row, for example, in this particular physical keyboard is the digits. The key codes plus the modifier keys, Shift, Control, Alt, Function, and so on. Each are understood by the program, or taken by a program, with the events. There's an event for people touching a key when it goes down, another key when it's, or another event when it's held, and another event when the key is released. And these are interpreted by a program called a keyboard driver program in your computer, and it looks up the character based upon the key code and other information in a table and decides what it's going to put there. And that table can be changed if someone wants to use a different arrangement of keys, a different mapping between what key one touches and what output is created. One changes this character lookup table in the middle. So instead of that particular position, which I have circled here, producing an A, if I would tell my computer, use the French lookup method, which would actually replace or use this position as the Q character rather than an A, all I have to do is tell the computer, use the French lookup table between the key code and the code that would come out, and it would produce the letter Q, and where the Q is on a QWERTY keyboard would produce the letter A. So this intermediation, this thing in the middle, that's basically a program to look up what each key means in terms of what character or characters is the key thing, so to speak, that differentiates a mechanical keyboard from a virtual keyboard. A computer keyboard is very flexible in that way, and so I can effectively reprogram a mechanical keyboard to produce all sorts of codes. And then the final step, which we'll talk about in a little bit, is to take this code, and the Unicode characters are generally represented as U and a plus sign and then a hexadecimal value. This code for A actually produces a shape on the screen because the application accepts the character, knows where to put it in a document or whatever the application is building. Then the application also says, oh, I've got a font and a particular style and size and rotation and other things are applied to that. And finally, the display is updated. So when I touch a key, it's actually a process of a number of steps to actually produce something on the screen. The beautiful thing is we don't have to think about that because programmers, engineers have figured this all out ahead of time for you, but it does indeed work. Now, if I want to take my physical keyboard and have it type Cherokee instead of the English language, what I would do is modify this program so that it uses a Cherokee key table, so that in the case of that first key in row C, which is normally the A, it would produce instead a character AB70, which is a Cherokee character, and that Cherokee character would be the one chosen from this. Now you can see I have a problem in my PDF here because when I generated my code, there was not a font that the PDF producer understood to make this character, so I'm getting something called tofu, which we'll talk a little bit about here. It's missing a piece. The font was not in place to actually produce this PDF. I apologize for that. In fact, you don't even need a physical keyboard. With many devices, touch screens, instead of having a physical keyboard, one can actually set up a place on the screen, and this can be a virtual keyboard. And so many of you have used virtual keyboards where a picture is drawn, and then where a person clicks puts that event into the input system, and it's treated exactly as if it were physical keys. And so you may have used a program like Google Translate where you can bring up the actual keyboard to be used, and that keyboard will map not only if you touch the particular places on the screen with this virtual keyboard, but will also remap the physical keyboard to type the characters needed in French. And you can see that this is the AZERTY layout that Google Translate happens to provide for French. Mobile devices use soft keyboards, and it's very much the same idea, but generally mobile devices use soft keyboards which are even more flexible. There's a keycaps table which says what shape should be shown in particular areas of the screen, and there can be multiple layers, just like there are shift and control and caps lock layers on a physical keyboard. They can be simulated by the soft keyboard, and there are options similar to what a physical keyboard has. Just like a key can be held to produce a repeat, a long press is available on many keyboards that enables a pop-up that lets you pick more options for each particular physical location on the soft keyboard screen. And this is from a program called Keyman, which is a very versatile keyboard input tool. Keyboards are really just special applications running on soft screen devices like tablets or mobile devices. And they can be built by many people. You don't have to wait until your software vendor or your computer vendor or your phone manufacturer decides to build a keyboard for yourself. There are many ways of doing this, and Keyman is one of the many tools that's available, a particularly useful one. Keyman also has developed many layouts already for mobile and desktop devices ready to install. And Keyman Developer is a tool that you can use on a Windows machine to build new keyboard layouts if you don't have what you like already. Here's an example of a soft keyboard. The one that I'm particularly familiar with is Gboard, which is a Google application. It's available to anyone with an Android phone, and many of the layouts are also available on iOS. But Gboard has already over 900 layouts available in many different languages, and you can see these are some of the languages that I have chosen to set up on my phone. This is a screenshot, and simply use the long press on this space bar to show all the keys which were added, or the keyboard layouts which are shown, and then I can change to any one of these. Here's a particular keyboard that happens to be on mine. I worked with some people in the south part of the Arabian Peninsula, and we added some pieces to a standard Arabic keyboard to make another one for the Mari language. And this particular keyboard allows people to type in that language because it has different characters used than standard Arabic, and so people can use this very easily for that language. The hardest part about using Gboard is figuring out how to actually find your language that's there. And many people I talk to who say, oh, my language isn't available on the internet, I don't know how to use it. I ask them to look on their phones and help them find that in many cases Gboard already has their language available. One just has to simply go to the language setup area, and one of those 900 layouts may be the language you need already. Not everyone is there, but we're working on it. As I mentioned, Keyman is another one where you can build your own input methods. A man named Mark Durden, who lives in Tasmania now, started doing this when he was a teenager in Laos, and he has developed this into a powerful application which works on almost every input device, or every device now, and it is now part of SIL, and you can find out more about that at keyman.com. As you saw, I had a square on my Cherokee output. I didn't do that intentionally, but it serves to illustrate a problem that shows up. You can have all the character codes you want. You can have your writing system in Unicode, but unless the particular device that you're using actually has the knowledge of turning a digital value for a character into a shape on your screen, you get what people call tofu. Tofu in computer language is a little white box with no flavor. So these are some of the symbols you may see if your keyboard doesn't, if your machine does not have a font for the characters you want. Google and others have realized that this is a problem, and so there is a lot of work being done to create fonts for all the writing systems of the world. And delivering them on mobile devices is one of the challenges these days. It's also important to note that these fonts may be used with multiple languages in the same document, and so it's nice to have them coordinated and synchronized so they look reasonable together. Google developed what's called the Noto Fonts system, and there are Noto fonts for most of the Unicode writing systems now, and Google is constantly adding new ones to that as Unicode defines new or adopts new standard writing systems. And those Noto fonts not only provide a way of displaying the characters, but when they are rendered together, if you Cyrillic and Noto for Chinese and Noto for Burmese, they all look relatively the same in terms of weights and styles. And you can find out more about this by looking at Google Fonts. But there are also many other fonts available for you to download on your own desktop or laptop. And many of them are publicly available for free. And if you want, you can also buy fonts. But it is really important to note, and this is one of the biggest frustrations about the language online right now, not every device makes it easy for you to add new fonts to your system, particularly mobile devices. Many of them make it very difficult. And that is partly because a font is not a passive piece of text or a passive piece of data. A font actually could contain some active element that would be potentially a security hazard. In this case, the phone vendors often make it difficult for users to add fonts themselves. But with each new release of Android and iOS, more and more fonts become available, so everyone will eventually be able to use most of the languages in the world. What is a font? Well, simply, a font is similar to the keyboard input method. A font takes a digital value, which comes in from some input method or from a file or from internet text coming in a web page or an application presenting different digital codes. Each of those codes is then looked up. This Unicode standard has representative shapes for a key, for a character. The shapes there are transformed by looking at a font, which is just basically kind of a lookup table. Given a particular digital code, it looks up the particular code in the font for the precise shape and sends that precise shape by effectively drawing the characters in your text, character by character, dot by dot on your screen. And you'll note that the shape here and the shape here represent the same character, but they are different in terms of the exact style of it. And the font determines what the shape is actually going to be. This is a particular language called Wancho. The Wancho script was fairly recently added to Unicode, but it's available on mobile devices now, and people are busy happily texting in the Wancho language using this particular writing system. When people want to use characters that are not available already, they can use tools. This is one tool called Font Forge. It is one of many that people can use either as free tools. Font Forge is one of them, off the internet, and run them, and they are used to actually make the specific shapes for each character, and although there are not, or although it's not something for, or it's not for everyone, it's not trivial to create a font. It does require some technical expertise and some skill. I've been able to create some fonts, not pretty because I'm not an artist, but these fonts can make it possible for me to show characters when I can't find a commercially available font. There are also tools available that you can pay for that have many more capabilities, and there are many videos online about how you use these tools to create the fonts in the way you want. So there are many font sources for you out there already. You don't have to buy them. You can get many of them for free, and the Noto fonts are all available online for your machine. Now, before standardization of a script is done, it is possible to actually have fonts that do not use Unicode because the writing system hasn't been standardized yet. And so very often people would take an existing font, would leave the numeric codes as they were, but change the shapes of those characters to represent the new writing system that is not yet available. And very often that's done by communities when they have some technical expertise to do this. This is what's called a font encoding, where you basically say, take existing codes, change the shape, and as long as I apply that font within my application on my computer, I can see the character shapes that I want, even though the underlying patterns of bits are very often the same as the patterns for A, B, C, and so on as in ASCII. That is a perfectly reasonable way of representing text in your language. However, it has some limitations. First of all, because the font has to be used to display the characters so they look right, that font needs to be available where you're showing it. If your font isn't on your mobile device, and generally a custom font is not, the characters will appear as they are in the standard font. So if you've used an ASCII encoding, you will get ASCII ABC rather than the characters in your language. And the text processing programs online, including search and email and every other application, will see the original codes because it will not understand that a particular font is to be applied. So this font encoding idea, changing the shape of the characters, works great as long as you are sharing the font and the text to anyone who wants to use it. But online, for applications such as social media or search or other applications, it just doesn't work very well at all. You basically get character output that really doesn't make any sense. Also, it doesn't know anything about the character properties if you're only using a font. It doesn't distinguish digits from punctuation from letters and other characters. Here's an example of a font encoding, just to give you an idea. This is a picture of the codes. They are all the ASCII range. 200 is a space character. 41 is a character, the capital A. 42 is the capital B. But the shapes have been replaced. This is lowercase. When installed on a particular machine, can be used to type characters in a particular font called Gentica for the Sunawar language, which is a not yet encoded writing system for the language, this language of Nepal and Sikkim of India. And so font encodings are surely possible, but they have their limitations. The Sunawar people are working to get their language in the Unicode standard, a process which does take a significant amount of time, but they've got it started. After Unicode standardization, many different writing systems become available on almost every device where there's a font available. For example, this is a BAMM, and BAMM has been standardized in Unicode. BAMM keyboard is available on Gboard, and there are characters available, or I'm sorry, there are keyboards available in Keyman and other places. But once things are in Unicode, then many things start working, although it does take time for the Unicode fonts and keyboards to be developed and distributed to every device in the world. As I said, one of the most difficult parts of Unicode characters and new fonts and new writing systems is the time it takes to roll out to every device on the internet, especially when people do not change their mobile devices very often. Older devices generally are not updated with new fonts and new keyboards. So very often people have to wait until a new phone is released before they can actually use their language if it's only recently been added to Unicode. It's also important to note that many people have been using font encodings not only to write text to their friends, but to create documents for education, documents for newspapers and printing, and labels for items in the store. And this is perfectly fine. But when the Unicode standard finally becomes able to support their writing system in their language, they may want to take their documents and convert them into a form that could be used, social media or on online websites. And this is possible by actually writing the rules that relate the character positions in the encoding font and replace them with the characters that are used in Unicode, just basically changing the numbers. There may be a few other little tricks needed, but this can be done in a program. And it does require some programming to do this. I personally have written some programs which will convert font encodings into Unicode for several different languages. And if you're interested, let me know. I might be able to help you with this. Here's an example of a language that is sort of supported now. This is the language, this is the Rohingya language, and the writing system is Hanafi Rohingya, which is in the Unicode standard. And this is included in Android after version 11. So this is my particular computer, and I can type in here with or I can read text that I've sent to myself. However, there isn't a keyboard available for it in Gboard yet, and those of you who know a little bit about this particular writing system will realize that Rohingya is written from right to left. So this text is actually not displayed properly in my phone because my phone doesn't understand that Rohingya is right to left. The character properties are not yet understood by this application. So, in summary, if you want to use your language online, you need a few things. You need standard characters defined. You need to find a font, and if you can't find one, you can work with people to build them. Build an input tool or find one that someone else has created. And then the new fonts and keyboards that have been created can be used by organizations all around the world. People can start posting social media, doing text to each other on their phones when both an input method and a font are available. And this opens up a great deal of opportunities for people all around the world. 3 years ago, a little more than 3 years ago, I was invited to Africa to go to Guinea, and I was going to a conference which was on the Adlam writing system. It's basically a conference on the ABCs that are used in the Adlam writing system. And there were 800 people at this conference, all excited about using their alphabet on mobile devices. It turns out that this is slowly rolling out as people get new phones in that part of the world, but now they are able to use Adlam for almost everything on mobile devices that are updated properly. And people are using the Gboard and Noto Fonts perfectly happily to write in this system. So I'd like to thank you for your attention. I would be happy to take any questions if I can figure out how to use my screen to find your questions. I would be happy to answer them. And thank you. Oops, excuse me. Unfortunately, I also have to figure out how to get back to my particular tools here. I'm used to other video methods. That is not it. Thank you for your patience. working on it. I'm sure you really wanted to see all of my great stuff here. Okay, so I see a few questions. How should we do this? Anna, do you want me to just answer the questions as best I can? Okay, so hello everyone. I see someone from Sikkim. Nice to see you. I see people from several different parts of the world. Heather Suter, hello. Thank you for joining. Language codes to make things findable is the question. Well, first of all, the language codes themselves are defined in standards. So look up ISO standard for language code and you will be able to find individual codes for the more than 6,000 or 7,000 languages that are available. And they can be added to documents. If you're building web pages, they can be added as the language in a language tag in HTML. If you're just setting some text up on social media or other place where you're posting text, however, it isn't possible to say, usually in most cases, that this text is a particular language. And that's one of the limitations of applications. I wish it were different, but not every program allows one to say, this is the text, or this is the language of my text. Some do, but the list of languages for most of them is limited. For example, in YouTube, I believe you can say the language of my video is one of about 200 different languages, but not all the languages of the world are there, and representing this is not quite as good as we'd like it to be yet. I see the question, am I helping communities to develop or to generate Unicode for languages? The answer is yes, I have, although that is not something that I've done a lot of. I work with people whose job it is to work with communities to take their writing systems and help get them into the Unicode standard. I also sit in the committee which reviews proposals. It's also important to distinguish here between language and writing system. There are many languages out there now which are written in writing systems that already exist. If your language is written in Latin characters or in Cyrillic characters or in Myanmar characters, you already have the ability in most cases to represent those characters on screen because the fonts are there. You may need a keyboard that includes more characters than are available in the standard keyboard for a language, just as the French keyboard includes things like accented characters and other variations that aren't available on the English keyboard. Your keyboards may need to be extended a bit. To get, so the answer is, if you have a writing system that you feel that needs to be added to the Unicode standard, you can contact me or other people and we can help you learn how to write a proposal for that. It does take quite a bit of time, sometimes years, to get things into Unicode, and then to get fully supported in terms of fonts and support on all the devices. It's a long process, but the best time to start is today. How difficult is it to get rare and unusual characters in Unicode in a variety of fonts? That is a challenge. One of the limitations is that font vendors, people who build fonts that we all use on our computers, have limited time to develop their fonts, and they also expect that only a certain set of those characters are going to be used in particular ways. They may not implement, for example, all of a particular writing system. I know that I've talked with some people about some characters which are actually incorrect or not drawn properly in the Canadian syllabics, Canadian Aboriginal syllabics writing system. This is not a fault of the Unicode standard, but it is when the font vendor either didn't know that the character was needed or drew it incorrectly. One of the ways of dealing with this is to, of course, contact font vendors and ask them, why aren't you supporting characters that I need? The other option is to develop your own characters. One nice thing about the Google Noto is that these Noto fonts for most of the languages are publicly available, open source in a repository called GitHub. If you want to tell the Noto developers that your characters are not being displayed properly or that you need to add a character, you can go and actually write comments for the particular font in that repository, and people are paying attention and will be able to address your questions and comments on these fonts. What new scripts are proposed for Unicode? The one that comes to mind that's in the pipeline right now is a font called a script called Mundari Bani, which is one name for it. It is a language, or it is a writing system of India, and it is not yet in the standard, but we expect it soon will be. I don't know exactly how to tell you which scripts were added to the most recent version of Unicode, Unicode 14, which will be released very soon, but you can use your favorite search engine and look up Unicode release scripts, and you should be able to find some Unicode system or Unicode documents which will tell you exactly what scripts were added to each of the Unicode standard releases. Let's see. Harder to understand the difference between a Unicode set and a font. Unicode really is a little more abstract than the idea of a font. As I said, the idea of a character in Unicode is simply a number. So the number 41 represents a capital A, but it doesn't specify whether it's a capital A that's angular or rounded or that has a script form. The font is what determines what exact shape it will be. It's a little bit like the teacher up at the front of the room saying, here are the shapes of the characters I want you to draw, and different kids in the classroom will draw each of those characters with a little bit of a variation. You can think of the individual students in the class as being the font developing their variations on the particular idea, the abstract idea that the teacher has posted to say, this is what the character is. But some kids are more creative than others, or like me, are not quite as artistic as others. Another question. So we have to memorize all the positions on the keyboard for virtual keyboards. Good question. In most virtual keyboards that appear as on-screen keyboards, there's an option to actually show where the characters are. And so you can actually look at this picture and say, oh, that's where that A with an accent is. Oh, that's where that particular character is. When a person knows the language, then it and the character set is fairly small, then it works out pretty well. When the character set is larger, and one example of a larger character set is Canadian Aboriginal syllabics, which has hundreds of characters, the input method may actually be a little trickier than one key per character. There is the whole category of phonetic keyboards. I personally just built and released something for Plains Cree syllabics. And this is in Google Input Tools, which works on the Chrome browser and also works on Chromebooks. And this allows a person to type one or more characters for each of the Canadian syllabics characters. So, for example, if I want to type the character that sounds like we, I hit W and E, and it produces that particular shape. If I want the woe character, I type W-O. If I want a longer O, I type W-O-O, and it produces, with a small set of rules, the characters that are indicated by the phonetic input that the user has given. And almost every one of these keyboards has an identified set of character inputs that produce particular outputs. In the case of Plains Cree, I can point you to the definition of this particular one. There is Gboard available for Cree syllabics? I do not know right off the top of my head, but I think so. One of the challenges of Canadian syllabics is that it's used by many different languages, used by Ojibwe, used by Plains Cree, used by Swampy Cree, used by different Crees, and they use different sets. So one keyboard probably isn't the right solution for that. And if you want more keyboards available for Cree or any particular language, contact me and I can at least advise you as to what's available. Let's see. So Gboard is what we already use. Well, you may be using Gboard, but because Gboard is just an application on your mobile device, you might be using somebody else's keyboard as well. You can download and use the Keyman keyboards or many other companies' keyboards on your machine. Just as you would unplug and plug a different physical keyboard in, you can sort of unplug and plug in new virtual keyboards on most of your phones. Even if you don't want to develop it themselves, go to either the Play Store or the App Store, and you can find lots of different options for keyboards that enterprising engineers have built. So we're going back still going back in time. What devices, for example, do not support user-installable fonts? Generally, most Android phones make it difficult to install fonts. I've been told, but I don't have one myself, that iPhones make it possible for you to install your own phones. Your own fonts. But almost every desktop and laptop that you own yourself allow you to install your own fonts. Of course, if you go to use internet cafe or somebody else's computer, that person or that institution may not let you add new fonts to your system. Let's see. Adlem is a cool looking script. I agree. And that is one where the original font actually has been augmented in several different ways by the people who originally created it. Let's see. So, what is it like doing Japanese input with Roman characters? That's a good question. I don't know exactly, but it's actually quite, because I haven't done it much myself, but it's actually quite similar to what you would do with the Cree input that I recommended. People would use a phonetic method, so they would type usually the consonant and then the vowel with it. It turns out that typing phonetically in Japanese is a lot like typing phonetically in Cherokee. For example, if I want to type phonetically on a Cherokee keyboard and I want to type the name of the language, I type TSA for tsa, LA for la, and GI for gi, and that produces the 3 Cherokee characters. Very similar thing would be done with a phonetic character for Japanese or other languages where people have developed a phonetic input. Typing those particular positions on the keyboard will produce it. And again, I'd be happy to use this, or to tell you about it. Last question that I see here, Gboard is just for mobile devices. Gboard is for mobile and Android tablets. It is not available on other, it is not available for desktops. But that gap is filled to some extent by Keyman and other keyboards that you can, software keyboards that you can find. There are also development tools for Microsoft Windows. There's something called Ukulele, which is a program that allows you to develop your own keyboards for Macintosh. And Keyman and these other tools, I think, will suit your needs. But before you go developing your own keyboard on these things, go to the stores for your mobile devices, look online for keyboards, soft keyboards that can be installed in Windows or Macintosh or other computers already. I know we've gone longer than I expected, but I have been happy to answer your questions. Keyboard, work on mobile and tablets. I think so. I know it works on iOS, and I know it works on Android. I believe that it also works on tablets, but I haven't tried it myself. But a Keyman version that I built for a language called Nigerian Pidgin, I delivered that to my friends who use that language, and it works on Android and iOS, and I believe it would work on a tablet as well. It turns out that Keyman has the advantage that if you build it once, it works on both soft keyboards and physical keyboards on desktop and laptops. Any other questions? I wish I could see you and hear you, but I'm happy to talk as long as you'd like. How many people need to use a new script for it to qualify for Unicode? That's a good question. It isn't the number of people who use the language that is important. To add a new script to Unicode, it's important to point out that it is actually used by people in a community for more than just an exercise in developing a new way of writing. The advantage of showing that a language actually uses these characters is that it's worth people's time to standardize the process for something that people are already demonstrating it in terms of if people are using the script, even in handwritten form, in newspapers or posters or public education or other forms, that demonstrates that the script is actually in use. It doesn't have to have a printed form. It doesn't have to have, it doesn't have to have books written in it. Many of the scripts that are added to Unicode are not for languages that are being used right now. Some of them proposed each year are actually for historic scripts, some of which haven't been used for hundreds of years. And in many cases, this is because people who study these languages want to be able to provide digital forms of these languages to use in publications, to use in archiving information about about the languages. And even though they're not going to be used tomorrow in the local newspaper, someone can still study that language and use it with the Unicode standard if it has been demonstrated that there is enough text that shows that it's a real use rather than somebody's high school or college project. Many of the writing systems that are actually in Unicode have been developed within the last 50 to 100 years. The one I mentioned, Mundari Bani, was developed by a man in the 1940s or 1950s, I believe, and it is widely used within the part of India where he lived, and he advocated for his language, for his community, and although he's been dead for a few years now, he has a central spot in the hearts of people who use the Mundari language in that part of India because he was such an advocate for their community and their language. And the writing system has been now proposed to Unicode and should be coming on soon. So it isn't the number of people who use it, it's the actual attribution of real uses that matter for getting something into Unicode. And having someone who's able to write a proposal that explains how the writing system would be used. And just like I described with Unicode and properties, the person has to describe each character in the writing system. Is it going to be punctuation? Is it going to be upper or lowercase letter, a digit, some other kind of character, a modifier character? Many languages have base characters, and then they have modifiers, combining marks like accents or other combiners. Those have to be defined. person has to define in what order these characters are going to sort. And writing a Unicode proposal is a significant effort, but there are many examples of these online. When I want to find out something about how a particular language is added to Unicode, I, in my favorite search engine, usually type Unicode, the name of the writing system, and the word proposal, and I will generally find the proposal that someone wrote to actually add that to the Unicode standard. All right, everyone. Well, I am going to close down the video. This will be publicly available, I believe, very soon. I really appreciate your engagement and thank you. And again, contact Anna if you want to get in touch with me directly. Kichimarsi and Wado and many other languages say thank you.